Let's move into another section, which is 711, and look at what are perfect squares. So with perfect squares, it's another way of factoring quickly, a little different than difference of squares. If you remember, with difference of squares, there were some important things that we had to note here. So remember that the number in front of the x and the number that's all by itself have to be squares, and this has to be negative. So some important things that we have to look at with difference of squares is, in this particular case, of course, a lot of the examples that you get are something like x squared minus 4. And of course, the 1 there is a perfect square. The 4 is a perfect square. We've got our negative. And if you recall, that one factors down to x plus 2, x minus 2, or vice versa. And then the second one would factor down to 2x plus 3 and 2x minus 3. With a perfect square, we actually have, instead of changing signs like the x plus 2 and x minus 2, this would be x plus 2 times x plus 2, or 2x plus 3 times 2x plus 3. So that would be what is known as a perfect square. So let's go through and look at what we need to see here. So first thing is, what expression can be substituted for a? So what can we plug in for a so that the equation is true for all values of x? So what we want to do is we want to replace the a to make this statement true. So the first one's pretty straightforward. We can just make a equals x, so we get x squared equals x squared. In the second case, we can make a equal to 3x. So then we get 3x squared equals quantity 3x squared. Notice the parentheses are necessary, so the parentheses are needed in number 2. And then on the third one, we can make a equal to 7x, because a squared means a times a, which is 7x times 7x. This bottom one, what can we make our a in this particular case? Well, to get the 25, first part is a would have to be 5, and the second part would be that we would have to put an x in there, because when we're squaring this, what happens is, and we haven't talked about this much yet, but when we're squaring this, as long as we're doing multiplication or division, and only in that case, we do 5 squared x squared, which is 25x squared. So that's where we get the 25x squared. And then on the last one, you have to think about what two numbers multiply to 1/4. So that would be 1/2, because 1/2 times 1/2 equals 1/4. We multiply across numerators and denominators. And so a would have to be 1/2 x. So therefore, a squared would equal 1/2 x squared. Just like the property above here, that would be 1/2 squared times x squared, which is 1/4, because 1/2 times 1/2 we already shown is 1/4 x squared. So therefore, a would have to be 1/2 x. In this case, our a would have to be x plus 1. So all we have to do is just plug it in there, and of course we get x plus 1 squared. And then in this last case, a would be 2x minus 9. And now we're starting to see some different ways to write perfect squares. And in the next one, we'll start getting into a little bit more about these perfect squares.